Hello. My target audience is a freshman sophomore class taking Intro to Computer Science here at Augsburg. Um, my topic for today is data storage via text document and its implications on the the old days when computers used to be the size of someone's house. Okay, so at some point, everyone has had to learn their ABCs. In fact, everyone that knows the English language knows their alphabet. But not just like we have to remember the alphabet, so do computers. Except computers store that information in a special way. The special way is is systematically measured through bytes of information, like megabytes, terabytes, kilobytes, gigabytes, all of these different sizes of storages or units of storage for a single file. All right, which brings us to my main point that was basically the basis for my project. So just how much memory does it take for a computer to remember a series of letters like the alphabet? What I'm going to go over really quick is in this presentation is just what my method was for my experiments, like what my initial setup was, and then I'm going to talk a little bit about the findings, and then I'm going to talk a little bit about what I conclude from looking at my findings and data. Okay, so as we've probably guessed at this day and age, we have a vast amount of information, and we have a vast amount of places to store that information these days. In fact, there's almost no limit. There's really no limit to how much we can store nowadays. There's basically terabytes of information where we can store billions of photos, hundreds of videos, all of these things. But what I feel is it's led us to be a little bit lazy in our coding. So what I suggest is to look at what it takes to actually code 1 byte of information and how much you can use that 1 byte for. Because when computers used to be really primitive and huge and used vacuum tubes, they would actually only have like megabytes or kilobytes even of storage. If you were lucky, you only had 1 gigabyte, and that even was rare. So for my presentation, I decided to figure out just how much information is being stored with the uses of only a couple bytes at a time to see what can be stored using it. This will give us this will kind of give us more of an idea of what it would have been like to live in that day and age. Alright, so let's talk a little bit about my method. I created a very simple 8-step method for my project. But the initial setup was my laptop, a text edit document like Notepad or text edit in a Mac computer. Then I needed a online database that would actually tell me specifically how much information or how many bytes a file would take up when it's stored in the memory. And then I would use that as a cross-reference later in my system. Alright, so my method includes like an 8-step process, like I said. The first step is basically to open the document, or text document, like Notepad, and insert what letters or strings of letters that I want to change and save in that document. Then I would save it, and I'd rename it by clicking on it twice to whatever experiment number it is. Then I would right-click on it, and then go down the menu to Properties, and then right away it'll show me exactly how many bytes of memory that file uses. And let's be honest, we can't exactly just trust this because this is an experiment where there's not a lot of variables, but there are some. Like for instance, sometimes computer companies like to, I don't know, be very complicated about their storing systems so they don't give them away to competitors. So what they'll do is they'll be a little bit sneaky and they'll say, well, this is like 0.75 kilobytes, or this is like 0.15 megabytes initially. But what I want to figure out is just the specific number of bytes stored. Okay, so after it tells you the number of bytes, I would record it and then move the file to my online database that would check the results for me and see if the file really does only take up that amount of bytes. And if it does, then I would say that the experiment was a success, and then I would repeat all 8 steps and go back to the beginning and do it again. And for each one, I would change like a little bit of what's in it. Like I would put like 1A or 2A's or like a whole series of numbers, and then I'd play around with whether or not they're caps or if they're lowercase, and whether or not there's spaces in between each of them. And I got about 11 of those. Okay, so my findings. I have a PowerPoint picture that explains this better, but it's basically a chart, and on this side there's the number of the experiment. Then in this part there'd be whatever kind of document it is, and all these are text documents, so that's fine. And then over here would be my actual what I got when I stored that file, how many bytes it took to store it. And then over here I would describe all of my variables that I changed in each experiment. That's my basic those are my basic findings. So what can I conclude from these findings? Well, there was a couple points that I was able to conclude, and that was basically one thing I noticed was, like, for experiments, as an example, my experiments 5, 6, and 8, I was able to figure out that capitalization really doesn't matter. Like, I put in an A, a B, and a C in one, and then I put the same A, B, and C in another file and saved it, but this time as caps, and I still got the same byte size when I saved them both. So that leads me to conclude that when you capitalize a letter, it doesn't matter when it's being stored, whether or not it's capitalized. And another thing I was able to conclude was that spaces really do matter. Because if the spaces didn't matter, then when we opened up the file later, all of the words would be jumbled up together and really close, so you wouldn't be able to tell. Sorry about that. The phone's being funny. So you wouldn't be able to tell. But anyway, for two of my experiments, I had all 26 of the characters for the alphabet, but then I'd leave a space in between Z and Y. And then instead of getting 26 bytes of information stored, I would get 27, which leads me to conclude that the spaces really do matter. The last thing I was able to conclude was that each character really represented a byte of information, which I initially concluded was, in my hypothesis for this project, to be true. So that proved my hypothesis, and that was like several experiments where that same variable was expressed. Alright, let's briefly go over what I did. So my method is very easy. Open the document, save it put in whatever you need, save it, check how many bytes in it, and store it, and write down the results. It's a very simple method, very easy. My findings, my data sheet, is very simple too. It's just got a couple columns of information and then each data set. So that's really easy. Again, just talking about the same thing. This is the part of the presentation where I talk about my weaknesses and strengths of my method. And to be honest, there really aren't any weaknesses besides the fact that it's a really long step process. Other than that, there's really no weaknesses when you're dealing with computers. Just what the method is. It's just you can't screw it up. For future implications or future research for this, there really isn't any. I mean, this is trying to picture ourselves in the past and trying to realize that we're so lucky to have all of this technology and memory to store everything nowadays. And that's just part of what my experiment was trying to prove and why it's important. So really there aren't any past experiments that talk about this subject in particular. It's just something I created. Alright, are there any questions? This is the part of the presentation I would ask for the questions. Okay.